I'm going to skip over a bunch of these modules you see over here. We don't have any interactions going on in the simulation. We don't have contact, although theoretically we've got a barbell contacting this barbell stand. But in our simulation, we're just applying a force over here instead of placing a barbell on top of it. So we don't need contact either. And we don't have any fields or amplitudes. We're gonna create our load as a pressure as opposed to an amplitude. If maybe you had an explosion going off and you were creating a finite element simulation for armor plating or a blast resistant panel, then you might want to go in with amplitudes, because in an explosion, the force generated changes with time, so you've got a sort of wave, and then you could use the amplitude module to create that force. We're going to go with simple loads. So I'm going to double click on loads, and it gives me the create load window. Here I'm going to name it load from barbell. Now the step I want it to be applied in is the loading step. If you recall, we have an initial step and a loading step. So we do not want this load applied right at the start of the simulation. We want the simulation to get ready and then apply it in the loading step. For the category, we're going to go with mechanical. You see, it's not even going to let us choose some of these other options. We just haven't defined enough properties in the simulation yet. And in the mechanical category, we want to go with a pressure load. We could go with concentrated force, but then you'd be applying it at a specific point. Whereas we want to apply it over this entire face in the U-shaped holder. So that's why I'm going with a pressure. Now, of course, you make different assumptions when you're running your simulations. You decide whether you want to model your force as a pressure or a constant force or a shell edge load. And this is going to change from simulation to simulation. But in this one, we're going to go with pressure because it makes the most sense. We click on continue. And Abaqus says select the surfaces for the load. Now you can select them individually or by angle. We're going to go with individually. Also, if you had defined surfaces earlier, such as in the assembly module, if you expand that out, you see sets and surfaces. In assembly, we could have given some of these surfaces names, identified them and named them. And now in the loads module, once we're back in, oh, it kicked me out for a second. So let me just fill this back up here. Once you're in the loads, it would give me the option of clicking here on surfaces and then picking out those surfaces that we'd identified in the assembly module. Since we haven't done that, we're going to pick out the surfaces right here within the loads module. And so I'm going to say select the surfaces individually. I'm going to click on that surface and then I click on done. So we selected the surface. Now Abaqus wants to know what kind of load I want to put on it. So for the magnitude, I'm going to say 400. Now I'm assuming this is an 80 kilogram barbell. So each barbell stand needs to hold the weight of 40 kilograms. And kilograms is a unit of mass. We want force. So I'm multiplying it by 9.8. Or, well, I'm multiplying it by 10 just to make the calculation easier. And I'm making that 400. So that's 400 newtons of force that we're applying. And as for the amplitude we spoke about over here, we haven't created one, so we're going to leave that at the default. And we're going to leave the distribution at uniform as well. And I click on OK. And you see Abaqus has created little arrows over there showing me that a force is being applied on the surface. I could zoom in a little closer for you, and there you see them.